Hope you enjoyed your PSTT, folks, and hopefully you'll be ready to study for the test that you're going to have next time. I'm operating in my 8th period class here, and we're going to go through the study guide. You may want to have a pencil and a little something to write on to go with that. So we're going to start right in at the top. Brief history of the atomic model. You don't have to know the names, you just need to know the model progressed through history. What was the first model we saw in our models of the hydrogen lab back there today, couple weeks ago when we started this unit? What was the Dalton model? How would you describe it? Yeah, so the billiard ball model. Then we progressed to Mr. Thompson's model. What was that? Plum pudding. And then we went to the Rutherford model, which is sometimes called the what? Solar system model, right? And then we progressed to, who was the first person we talked about in this chapter? Danish guy. Start with a B. Bohr. Yeah, we went to the Bohr model, which is what? That's kind of like the, what? Orbits. Yeah, orbits around the sun. And then what did we end up with? I mean, I know the model back there had 3 different ones, but ultimately what did we end up with? The quantum model, which some people call the electron cloud model, right? And cloud's a bad term because is a cloud really a physical thing? Cloud's a physical thing, isn't it? You ever been on an airplane flown through a cloud? It's kind of creepy, isn't it? You can almost see the pieces of the cloud. So it's not really a cloud because what is it? It's a wave, right? It behaves like a wave. So it's a wave cloud. What does quantized mean, and how does it relate to the quantum mechanical model? What does the term quantized actually mean? A fixed amount of energy. A bundle of energy, right? How does that relate to the quantum mechanical model of the atom? Guys, it's not that there's a problem with your volume. It's just no one is answering. Go ahead, Lizzie. And how do they get between them? How do they jump from one to the other? Those little bundles, right? Okay. So you have to have a fixed energy to be in an orbit. And then to move, you have to give or release quanta. What's another name for a quantum of energy? Photon. Are all photons visible? No. Can you have any kind of photon from radio down up to gamma? Yeah. Yes, sir. You could put a photon instead of a quantum. What's the only problem? Understand, I may use the word quantum on a test. I may use the word photon on a test. Sorry, we were interrupted for just a moment. Explain the quantum mechanical model of the atom and the contributions each people made to the model. What did Heisenberg do? We didn't talk about him. That's one section I skipped. Basically, what he was the guy that said that you can't know both the position and the speed of a particle at the same time. So you can't know. And what do we know? Electrons never quit moving. So essentially, what did he say? You can't ever really know where an electron is. You can only predict what? What did Mr. Schrodinger say? You can only predict the probability of finding it. So he did what? A math equation to predict probability. And I apologize for the font here because I'm not leaving much room. We'll have to have a couple breaks in here, guys, because you'll see more than one video on this. If I've got the free version of this, they only allow me 15 minutes. So I'll have to upload it, and then you have to watch another video. I'll give you the names of them in the website. How about Bohr? Right, can't be between the orbits. How about the famous, I can't remember where he's from. I think he's from like Belgium. De Broglie, or some people call him De Broglie, some people just call him De Bro. You just don't even pronounce the last part of the name. So De Bro, I like that better. He sounds like, hey, I'm De Bro, man. De Bro, what did De Bro say? That they act like what? Yep. So the electrons act like waves. So what happens if you put all that together? Essentially, what are you saying? Electrons act like waves, and you can change the shape of the wave cloud. And when you change the shape of a wave cloud, it takes energy to do that. And atoms can move between electrons can move between energy levels. You know, some of you on that one lab, the flame test lab, you missed one of the questions. And it said, what particles are responsible for the colors? Well, really, it's the electrons, right? Because the electrons have to move so that they can give off photons. Now, one could argue, you could say photons in there, and I didn't mark that wrong either. So ultimately, you're seeing photons of energy that are caused by the electron moving between the energy levels. What's actually happening, if you remember back on the model of the hydrogen atom, what's actually happened? All of our models back there show the electrons jumping between levels. What really happens? Remember if you did on the first one, if you did the Schrodinger model and you absorbed energy, what did it look like? You changed the shape of the cloud, right? So the cloud changes shape. When the cloud goes back to its original shape, it gives off a photon. I mean, that's what it all boils down to. All right, electrons, the next one's just a statement. An electron is really a wave probability cloud of 90% somewhere around the nucleus. What's the basic shape of the S, the P, and the D? What's the basic shape of the S, the P, and the D? Go ahead, Dalton. Sphere for the S. How about P? Figure 8 kind of thing. I like that. D. Clover. There's 4 clovers and 1 figure 8 with a donut. There's 4 of these and 1 of these. How many of these are there on a level? How many p orbitals on a level? 3. How many s orbitals on a level? 1. So we got a 1, a 3, a 5 here, right? Describe electrons using principal quantum numbers and sub-level letters. Essentially, they're just saying we just like it says there, there's 3 examples. Make sure you can tell me about an electron by its energy level and what orbital it's in and how many are in it. So if I wrote something like 4f7, is everybody okay with that? You know what I mean by that? All right, number and type of electron can be on each energy level. What kind of electrons can be on level 1? S, level 2, S and P, level 3, SP and D, level 4, SP, D, and F, and then we can go on and on and on and on. Any questions so far? I'm not trying to speed us up. I'm just trying to keep us moving. If anything there. Aufbau principle to write electron configurations. What's Aufbau principle? Electrons load into atoms. By increasing energy. Is that a nice, neat pattern like level 1, level 2, level 3, level 4, etc.? Now, where do they start crossing over? Where's the first place that an atom puts an electron that's out of order? In level 3, what happens? It goes what? It goes 1s, and we're done. Then it goes 2s, then it goes 2p, we're done. Then it goes 3s, 3p. Now 3d is supposed to come next, but what happens? 4s comes, and then we go back to 3d. Then we go to 4p. What's after 4p? Nope. 5s happens then. So we zip over to there. Then we come back to 4d. And then it goes on from there. But what was I trying to say by that here? I'm just trying to say, remember, they don't necessarily. There was a couple people on the homework that you just loaded them by level. So you missed them all past element 20. Excuse me, past 18. You'll be fine for the first 18 elements if you just load them by level. It's right past this element, though, which is our good friend argon. So anything past argon will not be in order. Greater than argon, not in order. Okay? Alrighty, that's page 1. What's page 2 look like? Well, we're really not done with page 1, are we? What's Hund's rule say? So it says, show the electron spins of an atom in orders of equal energy. Only time that applies is if you have orbitals of equal energy. Like, for example, the 3p. There's 3p orbitals. Let's take an example, sulfur. What's the electron configuration for sulfur element number, what is it, 16? 1s2, 2s2, 2p6, 3s2, 3p4. Where do those 4p electrons go? Into these orbitals. How do they do it? They have to go the same direction until they all fill up. Yes? And then one of them has to go the opposite of it. Correct? Yep. Got a lot of people on 5-1 that did this. Or maybe it was the lab. Yeah, it was the lab, I believe. That's wrong. That's correct. Don't make two pairs. Make sure you put one in and then pair them. Yep. Write an orbital filling diagram for electron configuration for various elements. Use the template. So basically I just did one here, didn't I? I just didn't do all these. So here's the electron configuration. This is the orbital fill. Okay? All right, guys, I'm going to stop this one and we're going to take a quick break and then I'll be right back with a second video.